Today, we will be discussing the subject of validating NLP data and models using the Deepchecks NLP package. So let's get started. On a note before we get started, during this session, feel encouraged to ask a question about the subject you want further clarifications on or stuff that you didn't fully understand. I will try and stop in the designated points to answer some of the questions. So a little bit about me. I've been in research for 5 years now. I've started in mathematics, then moved on to data science. I've been at Deepchecks for the past year now. Deepchecks was founded 3 years ago. It mainly deals with testing and monitoring machine learning pipelines. Nir, unfortunately, could not be with us today. He's responsible to many of the slides you're about to see. So credit to him for the amazing slides. And if you don't like anything, the blame is on me, obviously. We will start with an overview of common data and model issues. We'll dig a bit deeper into a few of them, specifically drift, shortcut learning, and segment deterioration. Next, we'll go to the main focus of this lecture, which is how to detect those issues. We'll start with general concepts, and then we'll move on to a hands-on demonstration on how you can use the Deepchecks NLP package in order to find and later on mitigate those issues. And finally, some future plans and really cool stuff that are yet to come in the future. So without further ado, let's get started. Common data and model issues. So anyone here which have dealt with putting machine learning models into production are familiar with the model lifecycle. In its basic form, you start by acquiring some data, then you train your model, and if everything goes right, you put it in production and shit does not hit the fan. Why does it happen more often than not? Because there is a lot of stuff that can go wrong. As you may know, the machine pipelines is full of potential pitfalls. Experienced people in the crowd must have encountered at least some of the bullets here, if not most of the bullets. Pitfalls can be found at the data collection phase, the feature engineering, or even in the model training and evaluation process. It is important to test for them in different steps when setting up the pipeline and to monitor them over time to keep the shit from hitting the fan. In this lecture, we will focus on a subset of those issues, starting with data distribution issues, most notably drift. What is drift? Drift is a situation where either the data, the labels, or the joint distribution between them changes over time. It can be categorized into two broad categories: data drift and concept drift. Data drift is where the data distribution changes over time, yet the relation between the data and the labels does not change. While concept drift represents the other side of that coin. The data distribution may or may not have changed, but the relation between the data samples and the labels did change. This is a bit of a tricky definitions to grasp, so I'll try to clarify with a simple example. Imagine that you have data of different patients, and that your label is whether or not the specific individual is at hazard of getting a heart attack in the next month or so. Data drift may be the case where rare region in the training set become more prominent in the test set. For example, when you started collecting your data, the population were mainly of youth, and later on, as they age, the population become much older. Concept drift is, for example, a scenario where people that were once considered in hazard for a heart attack are no longer considered in hazard due to possibly recent studies that determined that they are not in real hazard, or new medication that arrived into market which help them avoid such risk. Let's illustrate why drifting is important with an additional example. Imagine that you have a model that aims to classify sentiment toward brands. Specifically here, you are tasked to classify the sentiment toward Hillary Clinton. Prior to 2016, in general, pizza had a positive sentiment, which your model has learned to associate, and thus your model learned to associate pizza with a good sentiment. And brands that were mentioned in the same sentences as pizza were usually regarded as brands with good sentiment toward them. What happened in 2016? In 2016, there were some news in certain circles that associated Hillary Clinton and pizza with a criminal organization that operated from the cellar of pizza joints. So if prior to 2016, the word pizza were mainly associated with the good thing, and people that search for the term Hillary Clinton pizza are most likely people who have a good sentiment toward Hillary Clinton. After 2016, this is no longer the case. So if we were to compare the data of, let's say, 2018 and the data of 2015, and we would like to classify the sentiment of people search for the term Hillary Clinton pizza with either a positive or negative sentiment toward Hillary Clinton, the answer would be very different. This is a classic example of concept drift where the relation between the data and the label changed.
Yeah, so just a second, I want to say if there are any questions as I was speaking, feel free to just send them kind of as you go, and I'll collect them once in a while and kind of interrupt with the questions. So continue, Nadav. Sorry about that.
Yeah, for sure. I encourage sending questions. Hopefully they are not directly related to Hillary Clinton, as I don't want to get in trouble, but I strongly encourage questions. So far, we have discussed drift as one of the issues that can go wrong when deploying a NLP machine learning pipeline into production. Let's move on to another example. Shortcut learning, for those of you who are unfamiliar with the term, refer to a situation where a model fixates on simple properties of the unstructured data in order to make prediction. In the example here, we have two arguments regarding NLP. One is a long, repetitive argument made in Wikipedia regarding why NLP is pseudoscience. The second one is an argument by my really talented aunt that says NLP works. Imagine that you have a model that gets as input an argument and try to classify whether the argument is true or false. If the model was trained in a suboptimal manner or it was trained on suboptimal data, it's very likely that in this specific scenario, a model will learn something like, if I get a really long argument, it's most likely mean that the argument is true. But if I get a really short argument, the argument must be false. This is an example for a simple property the model fixated on, rather than to learn the deeper, more context-related properties it should. As a final example of an issue that can go wrong in a model, let's talk a bit about model degradation. Specifically, we'll discuss model degradation in a specific segment. Here again, we'll go over it with an example. So imagine that you have a model that tries to understand brand awareness based on textual intersection between people. Such a model, if it will absorb an interaction such as the one displayed here between two young people, really can easily infer that, okay, one of the individuals is explicitly mentioning Netflix as an activity for this evening, and the other one responds with prominent cheer to that question. The model can easily infer that both of those individuals are really into Netflix. And if this type of conversation repeats in a lot of the conversation between young people in the application, it's very possible that when asked, the model will predict the brand awareness for Netflix for this segment is really, really high. But of course, the individual in the crowd familiar with the term Netflix and chill know it doesn't really speak about Netflix. And for a survey conducted later on specifically on this segment of the population, we know that in reality, streaming in Netflix has a dramatic decline in views for the segment of young people. For this specific case, it's a demonstration on why we should monitor the performance of our model, not only as a whole, but also on specific segments to know how to handle them properly. So other than the question which I encourage you
Wait, Nadav, 1 second. Give a second to answer the poll.
Yeah, I'm not going anywhere.
I also want to say we had a question before that from Shital Kusal Borhade. Sorry if I got that didn't pronounce it right. About if you can elaborate a bit more on concept drift and data drift with example. So I'm not sure if the emphasis is more on just the examples or like on more about the meaning of the difference, but try to take it to wherever you can maybe.
Okay, so I'll try to like briefly go over the example I've used before with a bit of a clarification. The main difference between data and concept drift is whether the actual observation of what data you see in the distribution has changed, or whether the relation between the data and the label have changed. So if we go back to the example of patients and the label is whether or not this specific patient is in hazard of getting a heart attack. An example for concept drift, meaning the person remained the same. You had an 18-year-old male in good shape, but with, let's say, diabetes. And in the previous time you classified him, you said, oh, he has diabetes, he's in high risk of heart attack. But as the years go by and maybe a newer medical research was published stating that only if you have diabetes and no other condition, you are at no risk of heart attack. So if the model was trained on data before that study, it should have classified this young male as at risk. But after the medical study was published, the label associated with this person should now be not at hazard. So the data remain the same, but the label associated with a specific sample can change. And of course, that can happen across different regions. Okay, so.
And I'm leaving the poll open for the next minute. So whoever still wants to answer, please do.
Great, I'm intrigued.
I'm intrigued, and I'm going to publish it in a second after closing it.
Perfect. So you'll have one more slide to fill it.
For those of you that will be watching the recording here, so the poll is about what's the most frequent issue type in your experience: drifts, performance degradation in the segment, shortcut learning, dirty data, or other. So those of you that are kind of online with us, so I'd love to see your results, and I'm sure Yolan will show them kind of going forward. Nadav, just noticed it's almost 6:30, so that saves enough time for the notebook kind of.
Yeah, for sure. Okay, so we've discussed some common issues that can be found in model deployment, specifically in the domain of NLP. Let's discuss a little bit about how we can find those type of issues. We will group the type of issue into two broad categories. We have the integrity related issues and or checks, and the distribution and performance related issues. The main difference between those two groups is whether or not we have the need to generalize in order to detect the issue. In integrity, for example, if we take a simple issue such as misspelled words, you don't need to look at a group of samples to detect whether or not a single sample has an issue. But if you would look at distribution and performance, the only way to detect an issue is by looking at a group of samples together, which leads to how here in Deepchecks we can detect the different kinds of problems. In integrity, we can look at the raw textual unstructured data, but for distribution and performance, we'll have to transform into structured data on which we can run calculation. I've promised you this is the last slide before the poll results, so Yaron.
I published the results.
Yeah, but I think the results are nothing less than amazing. I'm surprised here. So
I'm completely surprised.
Yeah, I mean, I knew dirty data is pretty common. So okay, let me just say the results. Yeah, it's 58% said dirty data is the most common issue, where like performance degradation in segment is 2%. One reply out of the 45 now. I'm interested if everything here is in NLP, right? And then drift, shortcut learning, and other are all like 11 to 16%.
And folks, the ones that said other, I will really appreciate if you can send me examples either on chat to everyone or to me personally. That's really interesting.
Okay, so we don't have a lot of time, so I'll get on with it. Let's talk a little bit about how here in Deepchecks we transform the raw unstructured data into structure. So we have three different methods in which we can do that: metadata, properties, and embeddings. Let's start with metadata. So in general, metadata is any information that be collected from an external source on the text sample. For example, it can be information on the person who wrote the text, details on the when and where the text was published, or what effect the text had. Later on the demonstration, we will show how we can use this kind of information to provide valuable insights. The other method is properties. Properties is any information that can be derived from the text itself. So we have few categories of such properties. You have the core technical properties, such as average word length. You have a linguistic kind of properties, such as the language of the text. And you have more domain-specific properties, such as the subtopic of the text in relation to the general domain of the problem. And the third method in which we can transform unstructured data into structured data is embeddings. Unlike properties, embedding, which are a low-dimensional continuous vector representation of a sample, capture the essence of a sample, the essence of it rather than related properties, meaning that samples that are semantically similar should have semantically similar embedding vectors if the embedding calculation was performed well. Specifically here in the display, you can see an embedding representation of different books across two-dimensional space. We can see that books that come from the same genre are grouped together, meaning their embedding vectors are close. Let's sum up. So we saw three different methods to transform the raw unstructured data into structured data. Let's go over a bit on the main differences, advantages and disadvantages of them. Metadata, really accurate, really good for segmentation, but not always available and doesn't describe the text. Its correlation with the actual text, not that good. Properties are less accurate. They don't describe the semantic meaning of the text, but they are really good for drift and outlier detection. They do describe the text. Embeddings are most accurate when it comes to describe the semantic meaning of the text. They are also good for drift and outliers, but the problem in them is low explainability, which will be bad for root cause analysis and follow-up mitigation. So we covered for integrity, we keep the unstructured data and go over it in its raw form. For drift and performance, we take the unstructured data, transform it into structured, and then run our calculations. So finished with the theory. Hope it wasn't too long. Now let's move to our hands-on demo, which is the main attraction of this webinar. So what are we gonna have here? So in this notebook, we're gonna cover three sections. First of all, a section about how to create and what is basically the text data objects Deepchecks relies on. And in the second section, we'll go over data integrity checks, i.e. checks that run on the unstructured raw text. And on the third section, we'll go over drift and model evaluation checks that uses the methods I've just mentioned to transform the raw unstructured data into structured one. Okay, so let's get started.
Wait, so Nadav, there are a few questions kind of gathering up. So before you kind of dive in, so one of them is the question about if the notebook of the code is public. So I think the answer is not yet, but quickly, and if you want to kind of use it, then reach out and we'll kind of find a way to let you try it. And anyway, within the repo and within the documentation, you can find some quick starts, right? Nadav, did I get that right?
Yeah.
Okay.
And this notebook will be available once we release our next iteration.
Okay, great.
Yeah.
So that,
Which should be really soon.
okay, so
Yeah, for sure. And also to follow up on that, in the first and last slide of this presentation, you have a link to a GitHub repository containing this specific notebook, so you can run it on your own environment.
Okay, great. And Amir Gavrieli just found, I was about to look for it. So thanks, Amir. Found in our documentation a quick start that has to do with the text classification use case. So thanks, Amir. Another question you got here before you dive into the code is from an anonymous attendee. So, sure that anonymous attendee will be willing to share their name if there's a further conversation. But how does data splitting, how is data splitting affecting the drift? Splitting based on time seems to make more sense in terms of predicting on unseen future data. However, when you run the test, the data drift is big. What is the proposed method of splitting?
Yeah, so that's a really good question. Of course, when you run drift checks, if you have a batch of data that is all currently available for your model training, and you do a random split, splitting it to train and test to get a good evaluation of the model you have trained on a portion of the data. So obviously what that means is that you would like to split it in a smart way of sort, like if you have dates, so maybe you will take the last batch of dates and use that as a test set. What the value of running drift checks on those instances have is if you get significant drift between the train and test, even though you splitted it manually on your environment based on dates, it's a good indication that it will be a really good idea to keep sampling for drift as you deploy your model into production, because that basically says that in the domain your model will be operating, there is a good chance of continuous drift. So it doesn't really matter how you will split your data, because basically you have all the data in one place and you will train your data to be robust on all the data that you currently have. But it does mean that you have to pay close attention on what comes next. What is the distribution of data where you are going to deploy the model? If you have any information on that, you can modify your training set in advance to be more like the production environment. And if not, I highly recommend using a monitoring tool to keep track of things like that while deploying the model. Any other questions, Philip?
No, and even if there were, I'd tell them to wait. So we're curious.
Perfect. Yeah, let's not keep everyone waiting. Okay, so our demonstration. Before we dive deep, let's take a quick look at the dataset in hand. So here we have a dataset containing tweet emotions. The dataset has raw tweets collected from Twitter and metadata on the user that wrote them, specifically the user age, gender, where he's from. And our goal would be to analyze a model that, given a tweet, classify the emotion expressed in the tweet into one of four categories. You have happiness, anger, optimism, and sadness. So basically a classic multi-class classification problem. And here we can see a few examples of the data elements. So the first thing in our agenda is creating the Deepchecks text data. Deepchecks text data objects, it contains the raw text samples, the labels, and it can also store properties and metadata, as in this use case. It stores cache to save time between repeated calculation, and it has functionality for sampling and input validation. This basically is the base object on which all of Deepchecks run on. So it is basically crucial to create one before starting your process with Deepchecks. Specifically here, you can see we are mentioning the test type at hand and providing all the relevant information. Next in our agenda, before we get to the actual checks, are properties. We mentioned 3 methods to convert unstructured data into structured. Properties was a key one of those. Deepchecks offer assistance in this domain. You can choose one or two possible options. You can provide your own properties that you have calculated on the text, or you can use Deepchecks built-in functionality for calculating properties. If you would to use this auto calculation, you would come up with those properties. Side note, the list of properties keep expanding, so Hopefully, by the time you will run the notebooks on your environment, you will have even more properties. To go over a few of them, we have simple ones such as the average word length in the text, and more complex one such as the formality of the text. How formal was the language used in the text sample? Okay, so we have finished our, let's call it, initialization of the Deepchecks object. Let's move on to our first check section, data integrity checks. Normally, you would want to do those type of checks before training your model. You would want to find relevant specific problems in your data. 58% of you said dirty data is the biggest problem at hand, so I'm guessing most of you will agree with me on that. Specifically here, we'll start our demonstration with property text outliers. We are going to take the properties calculated by Deepchecks above and try to find weird samples based on those properties. So we're going to run the check on the train text data object we have created above, and let's review the results. So what we see in the figure is basically we have calculated the properties per sample, and here we can see the distribution of the property value across the different samples in the domain. If we hover, we can see specific example related to each value. For example, here we can see a sample with average word length of 5.21 and the actual sample. The red regions are regions which are considered by the Deepchecks algorithm as outliers. By going over the specific examples, we can get really interesting insight. Specifically here, if you look at the average word length, at stuff that are considered outliers, text whose average word is more than 11 characters long. How come that is the case? 11 characters long is really long in average to the English language. By looking here, we can see that the hashtags in Twitters commonly come without spaces separating between the different words. So if you would to supply your model with the raw text as is, it may have a hard time associating the different hashtags to the actual word meaning behind them. So a good idea might be to split or modify the hashtag words before feeding it to your model. Let's move on and review some more properties. For example, we can look at the categorical properties such as language. If we were to look at the language property of the different samples in our training dataset, we can see that the vast majority of them is in the English language, 95% of them, but also we have a lot of tweets in many different languages. Now our decision will split to two. If we aim for a model to operate in an environment which is solely English, we might consider just removing all the samples which are not English native. On the other side, if we aim for a model to be able to perform in environments which are not only English, we might need to collect additional data of those languages before training our model. We can see here there are more outliers based on different properties, specific toxicity. As you can imagine, in Twitters, you can find quite toxic tweets if you aggregate across everything. Okay, so just by running one checks, we already got two really good insights that we would like to implement before moving forward with our model training. Let's see if we can find some more. So the second check we are going to run is directly related to shortcut learning. We're basically going to run a check that will tell us whether or not shortcut learning is something we should fear in the domain we are operating in. How are we going to test it? We're going to check for property label correlation. What does it mean? We have the properties we have calculated before. We're going to try and see whether there is a strong correlation between one of the properties and the labels that the model can fixate on. If we find that one such property exists, we will take more considerable efforts after the model training to try and see whether it really did fixated on them or try to make it avoid it in the first place. So here, what do we see? If we ignore the toxicity one for a second, we can see there isn't a strong correlation between any of the properties in the model. But if we will take a look at the toxicity, we see that the value of correlation is not really high, but it's not low as well. This is something that we would expect in this type of domain, because let's recall, our objective is to classify the sentiment of tweets. We can imagine that tweets with really high toxicity can be related to tweets that their sentiment is anger. There isn't, because it's in a rooted problem of the domain, I'm not sure that for this case there is something we can actually do about it. But in any case, it's a good thing to note and to verify for problems later on after the model training process is completed. Okay, so I think, Philip, are there any specific question about the data integrity part before I move on?
So we have a few questions that came up. Two of them are from Jason. So yeah, one of them is, does Deepchecks natively support polars or just pandas? So I'm less familiar with polars, but Nadav, if you have an answer for that.
So as mentioned at the start of the lecture, currently Deepchecks NLP package is in, let's say, early stages. Currently, we have the alpha out in the open. We are about to release our beta later this year, the full version. So
later this year, Nadav, later this year sounds really, really late, like in November. No, we're going to release. No
public promises. Wait, it's recorded. No public promises.
No, we're going to release it in Q2. Okay, so that's really soon.
And Philip, don't worry, we also have written promises later in the slides.
Okay.
Yeah, so basically the short answer is currently no, but it's a really good suggestion, and hopefully later on.
Okay, and so now there's another question. So Jason had two questions related to polars, so I'll put both of them as kind of resolved. And then the next question by Nir is, how do we split a long hashtag into 2 or more meaningful words? Does Deepchecks have an inbuilt method for that, or do we do it manually?
Yeah, so the short answer is currently no. The longer answer is it's in the really near future. Yeah, Deepchecks currently works on a solution that could take the result of a specific checks and apply different types of mitigation to it. But again, I will not promise anything because Philip said no guarantees on recordings. But in general, this is a really good question. Specifically, currently, what you can do is you can extract from the check results, and specifically here, it's a general pipeline engineering that you can detect those kind of strings by looking for the hashtag and then going up to the end of up to the next space, basically, and splitting the words. There are external tools that assist in splitting English words.
Yeah, anyone that wants uncensored informal promises, join our Slack. It's in one of the links, deepchecks.com/Slack, and then there, there might be a bit less moderation about time estimations and so forth. So
yeah. Perfect. Okay, so I'll move on. So as of now, we have finished the section related to integrity. Basically, up to this point, we have used the data in its raw textual form to try and deduce insights. In the following section, we're gonna use drift and model evaluation related checks. Those kind of checks belong after you have trained your model and you aim to either verify the model is good enough for production or to detect problems and iterate through the learning process. So here I've saved you the trouble of waiting for the model predictions to be over, and I'm just loading them from a pre-created CSV files. We have a prediction for the train and the test data sets. Okay, so let's get started with our first check. When we deploy a trained model into production, as we saw in the previous slides, it is critical to verify that the data environment is similar to the one the model was trained in. This can be done by monitoring for drift in the data, the prediction, and the labels. We will start by verifying there is no drift in the prediction. So what the prediction drift...
I know I just stopped you for a question, but I want to stop you again because it's something that affects the previous part of the notebook and understanding. So another question from Jason. You may have mentioned it, but where did the properties file come from? Just separate analysis? That's the question.
Yeah, so the properties are calculated before the check and then stored within the text data object to be used for various checks. There are two methods to supply those properties. There is a method to supply them externally from a saved CSV files, or you can run a Deepchecks internal function that calculates them and store them for you. So either of the two options. Okay, so I'll get back to it or start with it. So we've mentioned that we want to monitor for drift between the train and the test dataset in the offline research phase and also going forward into the monitoring step. So we start off with the prediction drift. What prediction drift value is? It basically says not directly whether there has been a change of the distribution across the data or the labels, but whether it checks that from the model point of view, whether or not there has been a significant change in the data distribution. So we look at all the prediction the model did for the train, all the prediction the model did for the test, and compare the distribution. I will not go in details on how the distribution, the drift calculation is performed. Specifically here, it is performed by Kramer's V. There is literature in the Deepchecks docs explaining this method alongside a few more. But at core, what it basically does, it looks at the distribution of the train, distribution of the test, and says how different they are from one another. As we can see here, the drift score is really low because there is no significant differences between the train and the test when it comes to predictions. Okay, so we have verified that from the model point of view, there isn't data drift between the train and the test. Now, let's verify about concept drift. How do we do that? Basically, we want to look for drift in the labels. And when we run our drift calculation on the labels, we see a different picture. What we see here is that there has been significant change between the labels of the train to the labels in the train. Specifically, if we look at the class of optimism,
train versus test, yeah.
One.
Train versus test, not train versus train, but yeah. Okay, doesn't matter.
Yeah. So if you look at the optimism class, you can see that in the training set, only 3% of the training data belongs to that class. But when going into the production environment, into the test set, we see that 16 of the data belongs to the optimism class. The prediction drift that we saw before tell us that from the model point of view, there wasn't a significant change in the data distribution. But from the label drift check, we can see that there has been significant change in the label distribution, meaning we are in a case where the data distribution have not changed, the label distribution has changed. It is a really strong indicator that here we are dealing with a case of concept drift, where the relation between data and label have shifted. Another good insight we can deduce from that is we see that optimism is rare in our training set. So it is completely possible that some of the optimism tweets found in the test set, which is a lot, are underrepresented in the train set. And therefore, it's possible that our model will fail to classify them as it couldn't have learned how to classify them correctly. Let's try and verify this assumption. In order to do that, we're gonna look at a more concrete model evaluation check. Specifically here, we're gonna look at a label confusion matrix check. What the label confusion matrix does, it runs on the test set with its labels and predictions and try to see where our model get confused, hence the name confusion matrix. If we will go over to the row of optimism, you see this is the true value of optimism. We can see that only 80 instances whose true label value was optimism were correctly classified by our model. This in comparison to almost 250 examples, our model classified incorrectly. This really strengthened our hypothesis that because a lot of those examples were underrepresented in the training set, our model was unable to learn how to classify them correctly and indeed misclassify them at the test set. Okay, so a quick overview. we have mentioned that the drift-related checks to verify, to check for significant differences between the train and the test.
Okay,
We have seen in this scenario.
Nadav, there's one question. If the data that is used in the plot available in tabular format?
Yeah. So basically, all of Deepchecks tests have two functionalities. If you look at the result object, it has a display component and a value component. And if you were to access the value component, let's say if I'll access, actually result is reused in multiple times, but if we were to run the checks and access the value component, I need to supply prediction, never mind, because I override my own parameters because I'm a very bad programmer, but a decent data scientist. But basically, if you will access result.value, you can access the actual data supplied within the display, hopefully in a user-friendly format.
And Nadav, I hate to do this, but we're going to run another poll. So while you're speaking, we'll run the next one.
Yeah, go ahead. Perfect. So while you are filling your answer within the poll, I'll continue to our next section. So basically, what we have seen in those three checks is that
for this poll, there's no other. So if the answer is other, I think just send in the chat.
Yeah,
enough interruptions. Okay, so we've covered that in our model, in the specific train test split that we have created, there is concept drift, which is a major problem that models tend to have a hard time dealing with. We started off with seeing the different change in distribution and then verify that it does affect our model by running a performance check. Next up on our agenda is a really cool check, which does not run on data that we have previously used, but did talk about metadata. At the beginning of this notebook, for those of you who remember, it was such a long time ago, we saw that for this specific use case, in addition to the actual text, we have auxiliary information about the user who wrote the text. If we were to access the metadata within the text object, we can see that, for example, we have the amount of days the user has been a member in the platform, and so on and so on. We will try to utilize this information to gain additional insights on our trained model. So what we are going to do is we are going to run weak segments check. Basically, we're going to use the metadata columns and try to automatically detect significant data segments on which our model performs badly in comparison to its average performance across the data. So we are running the metadata segment checks. We are providing the text data as well as the prediction, and let's see what we get. So what we see here on the y-axis, we have the user region. We have divided our user based on where are they from and days of our platform. So on the left, we have users which are new to the platform. On the right, users which are been with us for a very long time. And this vision into the different buckets and the different the selection of the different properties is done automatically. The model, the Deepchecks algorithm automatically scan for different segments and try to find ones of interest. Specifically here, we can see that it has found a segment, specifically users that are from America, which are really new on our platform. Our model does a really bad job classifying the intent of their tweets. Possibly the user are young and uses a slang the model is unfamiliar with. It can be one of many different reasons. But what is important that on this segment, which is not that negligible, it's 6% of all the data in our data set, our model has an accuracy of 0.3 in comparison to an average accuracy of 0.7, which is major difference, and we will definitely want to take a closer look. We can look at other segments that were automatically detected. For example, here we can see that also for users which are young and are originated from Europe, our model performed badly. All of those are segments that should be further investigated as a post-processing process in order to find out how we can improve our model. Okay, so we have used the metadata to do automatic search for weak segments. Why not do the same, but based on our beloved properties? We saw that there are different ways in which we can turn the unstructured into structured. So why not use all of them? So let's do that. So here we are basically running same kind of mechanism, but instead of looking at the metadata columns, we are looking at the properties. Specifically, what our algorithm found.
Wait 1 second, Nadav, just because we're kind of approaching like the last part of the notebook, I wanted to bring up another question we had from Nir that also said, by the way, that this is cool in the chat. So thanks, Nirmal, much appreciated. So Nirmal asked, what do we do in this case? Do we train a different model? Like we identified the problem set segment-wise. What's the right approach to, it says improvise our predictions, but I think it means to improve our predictions. I hope I got that right. So you want to answer that?
Yeah, for sure. So that depends, because here we only get the information that, for example, this segment is one that our model performs badly on. It could be of one of two reasons. One, this region is really underrepresented in the train set, meaning the model did not have enough samples from this segment to learn on, which explain why it does a bad job classifying examples from that segment. So if this is the case, the simple fix will be to collect more data that derive from this particular segment and train our model on it. A different issue that might arise that we do have data from Americans which are new on the platform, but the type of tweets that Americans which are new on the platform wrote 3 years ago is really different than the type of tweets they are writing today. So in this case, we are back to the classic problem of drift, but here on a specific segment. And the same solution I talked about earlier apply also here. You can try and find and detect how the data looks in the actual production environment and adapt your training set to, or monitor it over time and make sure that such drift doesn't reoccur. Hopefully this answers your question in a good manner. If not, feel free to contact me and I'll be happy to discuss it further. Due to time limitation, with your permission, I'll continue. So basically the last check I'm gonna show you in this notebook is automatic detection of segments based on the properties. Above, we have seen how we can automatically detect segments based on the metadata. And now we can see that running the same kind of concept on the properties also provide really quality insights. Specifically here, the algorithm focused solely on the toxicity property. It does not need an additional property to find weak segments. Why is that the case? As we can see here, from a model point of view, the more toxic a tweet is, the better the model did in classifying it. What can be one kind of explanation to it? If a tweet is really toxic, as we mentioned before, its chances of being tweet representing anger is quite high. So the model has a really easy life when trying to classify tweets of that segment, which is represented in a very high accuracy score compared to the average accuracy. But we have a mirror image in the other part. If the tweet is really not toxic, it seems that our model gets confused and doesn't really know what to do. It's not the textbook shortcut learning, but it may be slight variation of it. Are there any additional questions?
Yona, did we do the poll results yet?
Let's give another 20 seconds for people to respond on we can do better. We're at 70%, which is good. But let's see if anyone is going to put more stuff into the poll in the next 25 seconds, and then I'll publish the results.
Okay,
Perfect.
Maybe just at a broader kind of set. I just want to say a few things a few things I said in the chat. I sent in the chat, and you can also see all sorts of links and how you can be helpful and so forth. So once you get the Deepchecks like alpha for NLP up and running on your own data, please reach out. Let us know you're using it. Even just knowing what it's being used for really helps us. And like a lot of our approach to being community focused and kind of going towards the community is, of course, it benefits also like everything we're working on. But a big part of it is also just on its own to give value to the community. And then the more feedback we get, from the community use cases, then there's a higher chance we'll just be able to deliver a better package. So reach out, in any different ways. Slack, mails, it's pretty straightforward. Philip at Deepchecks, Yaron, Nadav is exactly as it's listed here. And then also, I'm sure, Nadav will kind of dive into this a bit more, but future plans, affecting the future plans. Well, we have something we call golden users, which means basically you give your feedback, a higher chance of it getting implemented, try some things before they're public or even like in an alpha, and also get some swag, but you shouldn't come for the swag. The swag is a side benefit, of course.
Oh, swag is awesome, and this is
the results are in.
The results are in, and this time there is no big surprise, but actually I would say that the number of people that are using generative AI is slightly more than I expected. So it looks like generative is really catching up, and this is kind of reconfirms what everyone in the industry is talking about.
Yeah, but it's good to put the numbers behind it. Yeah, perfectly. So we'll get on to the final section of our webinar. So in this notebook, we have covered how we can use Deepchecks in a variety of instances during the model life cycle. Now let's talk a little bit about what is yet to come. And so I'll move back into the presentation. Yeah, so I'm hoping that you can see the presentation now. If not, someone should tell me. Perfect. So we have covered the hands-on demo. Let's talk a little bit about what's next in our immediate road plan. So the first thing that we are planning on adding is what we call a domain classifier, basically adversarial drift detection. We want to create check that verifies whether or not the actual text have changes. Instead of looking at the properties or the metadata or try and get a model overview of whether or not the data is changed using the prediction, we want to look at the data itself. We are planning to do so using the embedding, the last of the three methods to transform unstructured into structured data. And what an algorithm called a domain classifier, which basically means it takes the training set and the test set, and the model tries to distinguish between them. It tries to classify which example came from which. If it did a really bad job, that means the train and test distribution are really similar, and basically there is no drift between them. What I've talked about so far is a method to get a numeric value. Oh, you have data drift, or no, you don't have a data drift. But you want more than that. You don't have anything to do with me telling you you have drift. So we want to know why. Why do we have a drift between the train and the test? How does it look like? In order to achieve that, we're planning to use 2 or 3 dimension display of the embedding space across different and display various information on top of it. Specifically here, you can see a coloring based on whether the example belongs to the train or the test data set. And we have 3 relevant sub-regions. One region is really prominent in train, the other 2 are really prominent in test. If we were to ask our domain classifier, hey, which example do you think belong in train and which example do you think belong in test? It basically says what our intuition says. If example lies within a right circled section, the domain classifier thinks those examples should belong to a train, and for the other section, it believes those examples should belong to text. What can we do about this information? One thing that we can do is, okay, we have a cluster of samples that are really representable of the train, but not at all of the test set. So we can look at those examples and try to classify what is common among them. Specifically here, if you were to go over them one by one, or even send them as a batch to a smart generative NLP model, it can tell you that, for example, in the right region, the examples can be largely classified into one of two subjects, sport and customer complaints, which is basically all the sport-related text in the data. So this check does not only meant to be a quality detector of data drift, but also explainable so you can have something to do with it later on. Additional stuff we are planning to launch in the upcoming weeks, days, whatever, is support in additional use cases, token classification, information retrieval, maybe even more based on the result of the poll you have just seen. And one more really cool feature we are planning to add is to add a check that will provide value in the annotation process. We know annotation is a really big issue when it comes to NLP tasks, specifically in generative NLP. And we are planning to launch a check that, given the already annotated data, we can recommend which one of the remaining data elements you should annotate next. Two more stuff we are considering on adding is...
I just want to say, I know there are a lot of questions in the, both the Q&A and the chat. I don't want to cut Nadav off in this part, so I'll once he's finished with this part, then I'll address everything and send some to Nadav and someone answer quickly.
Perfect.
And once Nadav finishes this part, there is another poll asking you, what would you like to see next? So you can impact directly the product roadmap.
Yeah. Not in many points of time this is possible, so take advantage of the opportunity. Okay, so two more and final things that are big blocks in our roadmap for this package is creating a check that will try and measure the similarity between different texts, and specifically we'll use these similarity metrics to provide insights. For example, whether similar samples got a different label. This is most likely something you would want to know about. And also, which correlates with the 58% that stated that dirty data is the major issue in their NLP pipeline, we're gonna dramatically extend our integrity suite, providing more checks, such as misspelled words and so on and so on. Okay, so we have covered the future plan. Time for the poll.
Wait, before the poll, wait once. No, okay, doesn't matter.
We can put the poll while I'm answering questions.
Okay, so yeah, so as you answer the poll, first of all, just the poll, what's the number thing you would like to focus on the next, which is multivariate embedding based drift, annotation recommender, token classification, and IR support, additional integrity checks, or similarity checks. So it might sound a bit messy when I said it kind of there, but luckily you also have that in your screen. Now I just want to, kind of mention some of the questions that came up now. So Mendislian asks, I want to see the recording of the video. Where can I obtain this record? So I think it's going to be uploaded to our website, but that usually doesn't happen immediately after an event. Hopefully in a week, but if not, then probably in 2 weeks. Another one is a few people saying they'll definitely give Deepchecks a go. Thank you so much. Pip install Deepchecks. Do it locally. Don't be a hater and use Collab. You guys have enough trust that you'll use it a few times. Then you support about doing generative AI things. Yeah, again, it's not part of this webinar. We are working on it. Feel free to reach out if you want to kind of play with it.
I mean, whoever is interested in talking about generative AI, please reach out to me. Again, Yaron at deepchecks.com. I'll also write it
at the end of the slides.
You can also ask Bard or ChatGPT, when is Deepchecks planning to release, or when what happens. Maybe they'll be more correct than we are, but anyway. So now I'll start with the ones that I know how to answer, and then I'll give Nadav the other ones that I think are more kind of related to him. So yeah, actually all the last four I think Nadav are for use. Let's say.
Okay, but before you answer them, I'll move on to the next slide so you can look at a nicer picture while Philip is answering stuff. Yeah. Okay, go ahead.
Amazing. Okay, great. The Slack channel link is deepchecks.com/Slack. So, okay, so Nadav, so how are you binning the age feature? It's a question from quite a while ago, but around the segmentation time, I think.
Yeah, so basically the algorithm does select how to do the segmentation itself. It is based on a tree model, which does the splitting of nodes based on an internal logic. So it's not a predetermined set. It does not split it to an equal amount of bins at each time. One time you can get 2 bins as a result. You can get 8 bins, depending on the decision of the algorithm. I will say that the goal of the algorithm is to find significant segments, meaning it will not create segments of under 5% of the data. So it tries to find segments that represent at least 5%, whether they are splitting the age variable into 2 or to 8, it's based on an internal logic and your data, of course.
Right. And internal logic, of course, means open source logic that you can see in our repo.
Yeah, internal, but not confidential.
Okay, next one, Robert Dubuc asks, very nice, how are the segments found? Back around the segmentation in the end of the notebook.
Yeah, so I don't think I'll go into great details on how this mechanism works, but I will refer you to our documentation. Specifically, you can read the documentation of the weak segments check, where it is explained in more details.
I'll send it out.
Perfect.
Okay, great. So I won't do answer live yet one. I'll leave it and just type it in the answer there for Robert's question. Next question by Shitala Kusala Borhade. Not related to this. I know I'm probably getting everyone's name wrong, but I'm sure it's better than just not saying who asked what. So not related to this, but can you tell me how emojis are pre-processed from tweets in emotion detection? Are there any embeddings for emoji processing?
Yeah, so that's a really good question. I will not get into precise details because I don't think the model I've trained on the tweets are that interesting to the rest of you. So basically, in order to handle the hashtags, what we did is actually we splitted the hashtags into different words. And what we did with the emojis is that we classified them given an external data set into categories and just replace them with the name of the category that they represented.
Yeah, so I will say in the past, I remember in a lecture I was talking about data drift in NLP, and someone talked about I think it was the poop emoji that changed meaning over time, and you can see that embedding drift anyway. Really interesting. There are definitely some use cases where you'll use the embeddings of the emoji and or just sometimes it's an n-gram that's kind of includes emoji, but I think it is pretty straightforward that that you just treat it as a word in many different cases. Yeah. So let's put that as answer live, and then where does the ground truth of these properties come from? So maybe I'll say briefly, and Nadav, correct me if I'm wrong, but there's no ground truth. You have all sorts of models that do all sorts of cool things, and then you use them, and they don't have to be if you need them to be amazingly accurate, then make them amazingly accurate. And in some cases, you get a lot of information just from generic models that were trained on similar data or even on this data in an offline setting. But yeah, it's not crazy ensemble kind of setting where you have models trained to create properties and then it's part of the same pipeline. That's at least not the way we're approaching it. And correct me if I misrepresent.
No, you got it just right, but I will add that in the cases where you do need the pinpoint accuracy properties for your specific domain, or you have more interesting properties that we do not have in our default lists, as you can see in the notebook, you can supply them externally. You can calculate them offline on your text and supply the properties for the rest of the calculations.
I finished with the question. We're just waiting, Yaron, for how are the segments. Oh, I see how the segments sound. You sent it in the
I've sent it already. And in terms of the poll, interesting results. There are a couple of folks that haven't answered, so I'll give it another 30 seconds.
Okay, so I'll go over the slide you've been looking at for the past 5 minutes or so. So basically, join the party. There isn't much more to say. Philip have mentioned that we have a group of golden users which get a lot of perks. So if you think it's in your angle, so definitely apply. You will not regret it. You have the mails that we have promised. And yeah, basically that's it. Let's see the poll. Multivariate embedding based drift. That was my vote as well.
Yeah. I think Nadav, we actually this time surprisingly we actually did predict what's going to be the result.
Yeah, for sure. Surprisingly enough, token classification got only 6%, even though 20% of you said token classification is your use case. So I'm guessing it's not your main use case.
Exactly. Yeah, it's one of the use cases. It's not the main one.
Yeah, for sure. Interesting results.
Yep.
Okay, so I'll
just to say that loud for those seeing the recording afterwards, they won't have it. So multivariate embedding based drift is 31%, 25% is annotations recommender, additional integrity checks is 22, and then followed by the other ones, which is token classification, NIR support, and similarity checks. So
these are really interesting results.
So Nadav, we have another question.
A debate on. We haven't been able to come to a consensus within the company which one is more important. So the results are really interesting.
So guys, in order to be able to, so you basically now impacted our roadmap. We are going to use this, as one of the considerations when we decide what's going to be developed next. When Nadav gets off the call, what is he going to code next? More seriously, please join our Slack channel, and communicate the Slack community. Communicate with us via the NLP channel there, and via other channels if you're interested in Vision and in Tabular. We're going to continue and ask these type of questions in order to refine our product roadmap, and you have the opportunity to actually really influence it. And you will have more.
Yeah, for sure.
Yeah, okay, wait, another couple of questions. So one of them is, can we use embeddings instead of properties? So I'll give my initial answer. No, that's why we need other checks. But like part of the value and what you see here is, they're explainable. And then the explainability helps with some of these checks that you saw there. So, but we hopefully will have more support in the future. Okay, great. So Nadav agrees with me on one. And then there's another one, which is, could you suggest any Twitter data sets with text and emoji? So I don't have like a good one, like if there are any data sets that use like Twitter and emojis. So I think intuitively, I'd say that on the Hugging Face website, you'll probably have some. But
yeah, specifically, I've used one, I think a year ago. There is one that is similar. You have a tweet and you try to predict which emoji was attached to the end of the tweet, if that facilitates what you are looking for. Perfect. Okay, so basically that's all we have for you today. But as Philip said, we do these kind of talks quite often. So tune in, follow either Deepchecks or Philip directly on LinkedIn, and you can see those events as they appear. On a final note, thank you, and also encourage your feedback and suggestion as you have done with the poll so far. We feel that the incredible pace in which the package is growing and being adopted is greatly thanks to the valuable feedback that we have been receiving. And if this package is going to be used by everyone, which I hope it will, we will need a ton of help getting there. So please feel free to reach out. We want you to annoy us with as many texts and emails as you can. And again, thank you for your time, and I wish you peaceful validation and positive test results.